A very good morning, children. In this video, we are going to see very important term of this chapter, thermodynamics. The term is enthalpy. Hereafter, you are going to use this word very frequently. Enthalpy. What is meant by that? Enthalpy. Here, generally, enthalpy is a symbol. In a shortcut, we give it the symbol H. It is the heat evolved or enthalpy change we speak during a reaction. And the enthalpy change is the heat evolved during a reaction at constant pressure. At constant pressure. What is enthalpy change, children? Heat evolved during a reaction at constant pressure. But the enthalpy, how we give is, there is some relation for this enthalpy with the internal energy. With internal energy. How do we represent the internal energy? U. Internal energy is represented with the symbol U. The internal energy and the product of pressure and volume. When you sum up the internal energy and the product of pressure and volume, it is equal to the enthalpy. It is equal to the enthalpy. Enthalpy is symbolized with H. So what definition we give? It is the sum of internal energy and the product of pressure and volume. Enthalpy is the sum of internal energy plus product of pressure and volume. But generally this enthalpy, there is heat evolved in the reaction. At the starting of the reaction, some heat will be there. At the ending of the reaction, some heat will be there. Means there is heat change. The change in this enthalpy, is generally represented the symbol delta H. How is the symbol generally represented as the delta H? It is given as the change in enthalpy is it is equal to the heat evolved in the reaction. Condition is at constant pressure. What is constant, children? At constant pressure. Previously we came to enthalpy is equal to internal energy plus product of pressure and volume. So whenever there is a change in enthalpy, there will be a change in the internal energy. But what are they saying? At constant pressure, and there will be change in volume also. There will be change in volume also. So the change in enthalpy we are giving the form of definition. Enthalpy change of a reaction is the heat evolved in a reaction at constant pressure. So pressure is not getting changed at constant pressure. So we got one derivation now. What is the change in enthalpy given? Change in enthalpy is equal to change in internal energy plus product of pressure and change of volume. Here the enthalpy change, it may be some exothermic reaction or it may be some endothermic reaction. Do you remember, children, how is the endothermic reaction, some exothermic reactions given? What is an exothermic reaction? First of all, you say to me, what is an exothermic reaction? Exothermic reactions are those in which heat is evolved during the course of reaction. It is evolved during the course of the reaction. For example, you are burning carbon compound in presence of oxygen gas. Combustion is going on. It is giving carbon dioxide gas. What is giving? Carbon dioxide gas. In this reaction, the change in enthalpy is minus 393.5 kilojoules. Means this much of energy is evolved or released from the reaction. Or this much amount of heat is evolved or released from the reaction. So whenever heat is evolved or released from the reaction, such kind of reactions, what are we calling? Exothermic reactions. So the change in enthalpy for an exothermic reaction will be negative sign. Or is that given as the negative sign. Already mentioned, when heat is evolved from the system to the surroundings, it is given in the form of negative sign. But one more example I am giving for you in contrary. What are endothermic reactions? What are endothermic reactions, children? The reactions in which heat is absorbed. When you react nitrogen gas with hydrogen gas, it is forming nitric oxide gas. Is it not? In order to combine hydrogen gas and oxygen gas to give NO, which are already there in the atmosphere, you need to give some amount of energy. So the changing enthalpy is given as minus 180.4 kilojoules. I am just taking a rough value. Oh, sorry. It is plus 180.4 kilojoules. So during endothermic reactions, system is absorbing heat from the surroundings. So when the heat is absorbed to the system from the surroundings, it will be a positive value. So by knowing this positive sign or negative sign, we can say how is the reaction. Is it an exothermic reaction or is it an endothermic reaction? Generally, this change in enthalpy, the change in enthalpy with change in internal energy, we can observe the change in volume. The change in volume. For example, you have some solid. You are having some solid, and you are having some liquid, and you are having some gas. You are having some gas. Solid, liquid, and gaseous substances are there. And just given a little amount of heat for the solid, 1 degree rise in temperature. We does not observe much volume change. We do not observe much volume change. And here also in case of liquids, volume change is not observed. But in the case of gases, we can observe a volume change. In shortcut, if we take a cycle type, its pressure will be more during summer season. Is it not? Means with increase in temperature, volume of the gases are increasing. Volume of the gases are increasing. So what we are speaking, we can observe the change in volume very well in the case of gases. So with this change in volume that we are observing in the gases, we are bringing one new derivation out of the present derivation. Delta H is equal to delta U plus P W V. We are getting in another form which is very useful for the calculations. Do you know ideal gas equation, children? What is ideal gas equation, children? What is ideal gas equation? PV is equal to nRT. Is it not? PV is equal to nRT. During the enthalpy change, what we would like to bring is, during the enthalpy change, what is constant already? Pressure is constant. And not only pressure, temperature will also be constant. What will be constant? Temperature will also be constant. During enthalpy change, pressure is constant, and temperature is also constant. Is it not? During summer season, what is said? When the temperature is increasing, then the pressure in the gas cycle type will be increasing. Means if you make pressure constant, temperature also will be constant. Or if you make temperature constant, pressure also will be constant. So now, from this ideal gas equation, what changes you can bring? You cannot change the R, universal gas constant. R is the universal gas constant. What is the universal gas constant value, children? Universal gas constant value is 8.314 joule Kelvin inverse mole inverse. What is this one? 8.314 joule Kelvin inverse mole inverse. Or it is also written as 8.314 kilojoule. Kilojoule. If you are converting that into kilojoule, you need to multiply with 10 to the power of minus 3. Kilojoule Kelvin inverse mole inverse. So keep in mind, if you are expressing in joule, you will just express as 8.314 joule Kelvin inverse mole inverse. Or if you are expressing in kilojoule, you must multiply 8.314 with 10 to the power of minus 3. Why? Some children had questioned this one. We know 1000 grams is equal to 1 kilogram. Yes or no? Then 1 gram is equal to how many kilograms, children? Crisscross. So 1 gram into 1 kilogram upon 1000 grams. So gram and gram cancel. 1 upon 1000. Can you write this one as 10 to the power minus 3 kilogram? Yeah, do you agree with me? Similarly, now joule like gram, kilo, joule, kilogram. In that method, when we take in the kilojoule, we need to multiply that in the form of 10 to the power of minus 3. Now this universal gas constant value is also constant, either joule or either kilojoule you can use. Now what can be changed? The things that you can change are, there can be volume change or there can be number of moles. Either volume change you can observe or you can observe change in number of moles. Analyzing this one, see, in this reaction, let us assume initially during the starting of the reaction, initially the volume is given as VA, or you can write V1. Number of moles are Na, or you can write N1, R into T. And the final stage of the reaction, I am writing P into Vb, means final volume, Np into N into R, number of moles at the final stage. So how do you differentiate any reaction? Final minus initial, or can you could write P of Vb minus Va is equal to Nb minus Na into R into T, because this is also known as V2 minus V1 or N2 minus N1. Or can you write P into change in volume is equal to number of moles of the gaseous substances. Change in the number of moles of the gaseous substances. Delta G means change in number of moles of gaseous substances. Already we came to know about this delta Ng. Number of moles of products that are present in the gaseous state minus number of moles of reactants that are present in the gaseous state. In this method we can calculate the delta Ng. But what is the use of the writing this one? Because we came to know internal energy is, change in enthalpy is equal to internal energy plus P into delta V. Substitute this value P into delta V is equal to delta Ng into R into T. So you are able to derive an equation where you are able to write the change in internal energy is equal to change in enthalpy is equal to change in internal energy plus delta Ng means change in the number of moles of gaseous products minus gaseous reactants into R into T. So basing on this equation, we are doing 2 to 3 problems. Write on these points. Let us see one of the numerical here children. The numerical is given as the data like calculate the difference in heat of a reaction. Calculate the difference in heat of a reaction at constant pressure and constant volume. At constant pressure and the constant volume. For the reaction, 2 moles of C6H6 liquid state plus 15 moles of oxygen gas plus 12 moles gives rise to 12 moles of carbon dioxide gas plus 6 moles of H2O liquid at 25 degrees Celsius. What did they ask us to find out? They asked us to find the difference in the heat of a reaction. How to find difference in the heat of a reaction, children? Difference in heat of a reaction. Do we know about this equation? What equation do we know? Delta H is equal to delta U plus delta Ng into R into T. The difference in the heat of a reaction is given as change in enthalpy minus change in internal energy. Change in enthalpy minus change in internal energy. It is equal to delta Ng into R into T. So once we know the delta Ng into R into T, what is the delta Ng? The number of moles of products that are there in the gaseous state and number of moles of reactants that are there in the gaseous state. What are the number of moles of products present in the gaseous state? In the products, 12 moles of carbon dioxide gas are there and 6 moles of water liquid state is there. So gaseous products, there are 12 moles minus number of moles of gaseous reactants. Here benzene is the liquid state, we need not to consider. 15 moles of oxygen gas is there. 12 minus 15, how much you are getting? Minus 3. So delta Ng you can say it is equal to minus 3. How about R value? R value is equal to 8.314 joule Kelvin inverse mole inverse. Or you are going to use this one as 8.314 kilojoule Kelvin inverse mole inverse. Then what the temperature given? 25 degrees Celsius. So you need to add this 25 degrees Celsius plus 273, 298 Kelvin. So you substitute the values. Delta H is equal to, delta H minus delta U is equal to minus 3 into 8.314 kilojoule Kelvin inverse mole inverse Kelvin inverse mole inverse into temperature 298 Kelvin. Here it is minus 3 moles. Is it not? Minus 3 moles. So straight up the units first, Kelvin and Kelvin inverse, mole and mole inverse you can strike off. Some calculation you will be getting some minus value. The unit will be kilojoule. Unit will be kilojoule. So in this method you can solve the problems for taking the formula delta H is equal to delta U plus delta Ng into R into T. Let us see one more numerical on this topic. Let us see one more numerical given here tonight. This is the application type based on numerical. Let us see the question once. The question is given as a swimmer coming out from a swimming pool is covered with a film of water, means over his surface film of water is there, weighing about 18 grams. How much is the weight of the water weighing? 18 grams. How much heat must be supplied to evaporate this water at 298 Kelvin? Second thing, calculate the internal energy of vaporization at 100 degrees Celsius. Internal energy of vaporization at 100 degrees Celsius. Enthalpy of vaporization of water. Enthalpy of vaporization of water is 40.66 kilojoule mole inverse at 300 Kelvin. Very stupid question. Now, how do you know how much of internal energy change will be there? Yes, whenever there is a change in internal energy and a change in enthalpy value is given for you. You recall this problem. Change in enthalpy is equal to change in internal energy plus delta Ng into R into T. But here they are asking us to calculate the internal energy of vaporization. Here the internal energy of vaporization is equal to internal enthalpy change of vaporization minus delta Ng into R into T. So you need to calculate this enthalpy of the change in internal energy of vaporization. So first of all, already in the question, the enthalpy of here, whenever there is a knot, it says the standard enthalpy of vaporization. Standard enthalpy of vaporization. See, if everyone knows what the boiling point of water means, you will say 100 degrees Celsius. Similarly, there will be a standard unit for every substance. That value they will be given in the question. The standard enthalpy of vaporization of water is given as, how much it was given tonight? 40.66 kilojoule mole inverse. Mole inverse. Let me check the question. Is it 40 kilojoule or 40 joule inverse? Very good. Kilojoule mole inverse. Now, what you need to know? You need to know about the number of moles of the gaseous state. Generally, H2O present in the liquid state, it will be converting into the gaseous state. It will be converting into the gaseous state. In the gaseous state, in the liquid state, its mass is 18 grams. In the gaseous state, also its mass is 18 grams only. But how to know number of moles? Number of moles is equal to small w by capital M. What is small w? Given mass by molar mass. Given mass by molar mass. Don't forget this value. So number of moles is equal to, what is the compound they have given? Water. How much of film of water? 18 grams they have given. So given mass is 18 grams. What is the molar mass? Expressing grams in mole. Where 1 mole is called as the molar mass. Its unit is the molar mass of water is also 18 grams mole inverse. So this grams and grams, if you cancel out, number of moles is equal to 1 mole. Number of moles is equal to 1 mole. Very simple, right? But now we want to know what is R value. R value you can take as 8.314 joule Kelvin inverse mole inverse temperature. How much is the temperature they had given? 298 Kelvin. Already they have mentioned the temperature 298 Kelvin. So substitute these values to them. What values are going to substitute? Delta enthalpy of vaporization is equal to change in enthalpy. What is the value? 14.66 minus 1 into 8.314 into 298 Kelvin. So you can solve this type of problems. I hope you understood this application. In the next session, we will continue with the remaining concepts. Thank you, children.